operations with radical expressions, and that's adding and subtracting and multiplying radicals. I discussed dividing radicals in my last video, which was simplifying radical expressions. So if you need to know how to divide them, you can look at the video simplifying radical expressions, and that'll explain that. But now we're going to talk about multiplying and adding and subtracting radical expressions. Now for multiplying radical expressions, again, a radical expression is any expression that contains a radical. We need to multiply the coefficients, which are the numbers in front of the radical. Then you multiply the radicands, which are the numbers underneath the radical. And then, if it's possible, you simplify the radicand, which means that if there's a perfect square inside of the radicand, we have to simplify it further. And I will go over that a little bit in this video again, but I've done that in my last video, which was simplifying radical expressions. So to start, we multiply the coefficients, and then we multiply the radicands. So I'm going to do 3 times 2, which gives me 6, and 2 times 6, which gives me 12. Radicands must stay underneath the radicand. Now 12, I can factor, and that gives me a 3 times 4, and 4 is 2 times 2. 4 is a perfect square. So that 2 can come out. The 6 doesn't go away. There's a 2 there. The 3 has to stay behind. And so in perfect simplified form, 3 times the square root of 2 times 2 times the square root of 6 ends up giving me 12 times the square root of 3. And I know I went through that quickly, so let me go over some more. Multiply the coefficients, 9 times 4, and the radicands, 2 times 10. 9 times 4 is 36. 2 times 10 is 20. 20 has a perfect square in it, 4. So I can take that perfect square out. Basically, I take the square root of 4, and I get 2, and the square root of 5 remains behind. 36 times 2 is 72 times the square root of 5. 2 times 5, 6 times 3, and I get 10 times the square root of 18. 18 is 2 times 9, and 9 is a perfect square, 3 times 3. So the 3 will come out, and the 2 gets left behind, and I get 30 times the square root of 2. And I should be boxing those. 3 times 2, 5 times 5. Now this one, I'm going to go ahead and multiply it, but if you multiply 2 matching radicals, the square roots cancel each other out because essentially you're squaring the square root. So we could skip this next step here where I do the square root of 25. The square root of 25 is 5. So this will simplify to simply 30. Okay. If we're adding and subtracting radicands, we think of the radican like a variable. We can only add like terms. Okay, so square root of 2, square root of 2, square root of 2, these all match. So what I'm going to do is I'm going to add or subtract the coefficients. Okay, so 5 plus 7 and minus 6. 5 plus 7 is 12, minus 6 gives me 6, and the radical stays the same. On this particular example, 13 times the square root of 2, negative minus 5 times the square root of 2, plus 4 times the square root of 2, so I have 13, not 12. 13 minus 5 plus 4. 13 minus 5 is 8, plus 4 is 12, and the square root of 2 stays the same. Up here I have square roots of 7, and square roots of 11. These don't match, so I can't combine those. So what I can do is rearrange this if I need to where I put matching terms next to each other. You don't have to rearrange them, but if it helps you visually to rearrange them, then you can do that. And you can also double check and make sure you've got all your terms. And then I have 10 and 4, so that's 14 times the square root of 7. And 5 minus 6 gives me negative 1. Well, I don't need to put that 1 there. So I just say minus the square root of 11. 4 times the square root of 3, 11 times the square root of 3, 14, and 6 times the square root of 5. Now keep in mind when you do this that negative 11, if you're going to rearrange them, it has to stay with the 11. And the negative has to stay with the 14. Okay, so 4 minus 11 and 14 and 6. So 4 minus 11 gives me a negative 7 times the square root of 3. And negative 14 plus 6 gives me a negative 8 times the square root of 5. So keep in mind that these are just like variables. If they don't match, you can't combine them. Okay. Which brings us to, what do you do if they don't match? Well, if they don't match, the first thing we want to do is simplify. Okay, so we'll simplify each radicand. And then I will add or subtract like terms. I don't know why I put a step 3 there. Okay. So I'm going to move these over a little bit so I have more space. So 2 times the square root of 18. 18 is 2 times 9, and 9 is 3 times 3. That's that perfect square there. So this becomes 2 times 3. This 2 didn't go away. And then this 2 stays underneath. So this is 6 times the square root of 2. So I'll replace the 2 times 18 with a 6 times the square root of 2. And then I have 2 times the square root of 32. 32 is 2 times 16, and 16 is a perfect square, 4 times 4. So that 4 comes out, and this 2 stayed behind, and this 2, no, sorry, that shouldn't be an equal there. So I get 8 times the square root of 2. So 2 times the square root of 32 becomes 8 times the square root of 2. And the square root of 72, 72 is 2 times 36, and 36 is a perfect square. And so I get 6 times the square root of 2. Now I can add my like terms, and I have 6 plus 8 plus 6. So that's 14 plus 6, so that's 20 times the square root of 2. Okay, so you're going to simplify first, and then you'll add like terms. So this one was here, this one was here, and that one was there. Okay, let's try another set. This time I'm not going to move off to the side, so you can see how you would combine them all together. 54 is 2 times 27, which is 3 times 9, which is 3 times 3. So I can pull out that 3, and this 6, the 2 and the 3 get left behind. And 24 is 2 times 12, which is 3 times 4, which is 2 times 2. So I can pull out this 2, and the 6 gets left behind. And so I have 12 times the square root of 6 plus 4 times the square root of 6, which gives me 16 times the square root of 6. I can simplify here. 12 is 3 times 4. 4 is a perfect square. And 3 gets left behind. Okay. 48 is 3 times 16. Although if you didn't know that, let's go back and you know it's even, so it'll divide by 4 or 2. I curved sideways so I don't run into myself. I have 2 pairs of 2's and a leftover 3. So 2 2's and a leftover 3. So I have 8 times the square root of 3 minus 6 times 2 is 12 times 2 is 24. And 8 minus 24 is negative 16 times the square root of 3. Okay. And you'll do that for however many terms you have. 45 is 5 times 9, which is 3 times 3. So this gives me a 3 that's already there. And the 3 I pull out with a 5. 5 times 4, so 2 with a 5. 5 times, and so here's another good thing. Once you've got the first one as a 5, you can use 5 every time to try to see if that is going to match. So 245 divided by 5 is 49. Now I would have divided that one by 5 anyway because it ends in a 5, but the fact that these had a 5 left behind gave me the indication that that one would also leave me with a 5. So I get 6 times the square root of 5 plus 2 times the square root of 5. Sorry, wow, that was terrible. 3 times 3 is not 6. 3 times 3 is 9. So 9 plus 2 is 11, minus 7 gives me 4. So my final answer is 4 times the square root of 5. 24 is 4 times 6, and 4 is a perfect square, which lets me think that these are going to each divide by 6. And have 6 left over. So I can take that 54 and divide it by 6, and I get a 9. And the square root of 9 is 3. And I can take that 96 and divide it by 6, and I get 16. And the square root of 16 is 4. 2 minus 3 is negative 1, plus 4 is 3. Okay, so we discussed multiplying just simple radicals together before, but now we can multiply monomials and binomials. And we want to distribute, so we'll multiply each of these. And what I end up with is 3 times the square root of 5 times 2 times the square root of 5 plus 3 times the square root of 5 times 5 times the square root of 3. And so we're going to be combining a couple of options here. First, multiplying radicals. So 3 times 2 and the square root of 5 times the square root of 5. And that is going to give me 6 times the square root of 25. And then 3 times 5 and the square root of 5 times the square root of 3 is going to give me 15 times the square root of 15. We want to see if we can simplify each of these. Well, 25 is a perfect square. So this is going to give me 6 times 5 plus 15 times the square root of 15. The reason I didn't simplify this is 15 is 3 times 5, nothing matches. So this is going to give me 30 plus 15 times the square root of 15. And that's as far as I can go because I can't add these. They're not like terms. So again, distribute. And I'm going to get 3 times the square root of 2 times 4 times the square root of 3 plus 3 times the square root of 2 times 6 times the square root of 2. 3 times 4 and 2 times 3. This will give me 12 times the square root of 6. 3 times 6 and 2 times 2 will give me 18 times the square root of 4. 6 is just 2 times 3, so that is not going to simplify. 18 times 2, since the square root of 4 is 2. So that is going to give me 12 times the square root of 6 plus 36. And then finally, if I have a negative, we need to take that into account. Okay, so 5 times 3 is 15, 3 times 2 is 6, 5 times 1 is 5, and 3 times 3 is 9. So I'm going to get 15 times the square root of 6 minus 5 times 3. 15 times the square root of 6 minus 15. And again, not like terms, oops. So I cannot combine those. Now if I have binomials, we talked about this a little bit in my last video with conjugates. I have to FOIL these. So first, outside, inside, and last. FOIL. What I end up with is 3 times the square root of 11 times 3 times the square root of 3. That's first. Outside gives me 3 times the square root of 11 times negative 2 times the square root of 2. Let me number these because I'm not going to be able to fit this. Okay. Inside is going to be 3 times the square root of 15 times 3 times the square root of 3. And last is going to be 3 times the square root of 15 times negative 2 times the square root of 2. Multiply those out, and I get 9 times the square root of 33 minus 3 times negative 2 gives me a negative 6 times the square root of 22. And then 3 times 3 is 9 times the square root of 45. And then minus 6 times the square root of 30. And now I want to see if I can simplify any of these. 33 is 3 times 11. 22 is 2 times 11. 45 is 5 times 9. This will simplify. And 30 is 2 times 15, which is 3 times 5. So this is the only one that will simplify. And I'll get 9 times the square root of 33 minus 6 times the square root of 22 plus 3 times 9 is 27 times the square root of 5 minus 6 times the square root of 30. Nothing else matches or can be simplified. So that one's done. And I'm going to go ahead and I'm going to take this one and I'm going to move it to another page. So I'm going to FOIL it first. Gives me the square root of 3 times the square root of 15. Outside, square root of 3 times the square root of 12. Inside, square root of 2 times the square root of 15. Don't forget your negative there. And then last, negative square root of 2 times the square root of 12. 3 times 15 is 45. 3 times 2 is 6 times the square root of 2 times the square root of 12. 3 times 3 is 9 times the square root of 2 times the square root of 2. 3 times 4 is 16 times the square root of 2 times the square root of 2. 3 times 5 is 25 times the square root of 2 times the square root of 2. 3 times 6 is 24 times the square root of 2 times the square root of 2. 3 times 7 is 24 times the square root of 2 times the square root of 2 times the square root of 2. 3 times 8 is 16 times the square root of 2 times the square root of 2 times the square root of 2. 3 times 9 is 16 times the square root of 2 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 times the square root of 3 times 12 is 36. 2 times 15 is 30, and 2 times 12 is 24. 45 is 5 times 9, and 36 is 6 times 6. 30, 2 times 15. 24 is 4 times 6. We have perfect square, perfect square, perfect square. So these will simplify to 3 times the square root of 45 plus 6. This one doesn't simplify. And then nothing else matches. So we can leave it just like that. And that is how we multiply and add and subtract radical expressions.